First of all, I'm really happy to be here in PolyConf at Poznan. Like Zaiste said, I was meant to be here, and I'd like to thank every one of you for making this possible. This is really amazing. And before starting, I'm gonna ask you a question. Does any of you know what that red thing is? It's a fez? Yeah, great. And yeah, it's a fez and fezes are cool. I like fezes. Probably I'm Turkish, that's why. So, I'm Serdar Dogruyol from the most beautiful city of Istanbul, Turkey. I'm a long-time Rubyist and a recent Crystal evangelist. I'm the organizer of Ruby Turkey and Crystal Turkey. I'm an open source developer. And mostly I work on Crystal and related stuff. I'm literally a polyglot person. That's why I'm here. I speak like 4 languages, including Japanese. Maybe some of you get that reference. I hope so. So I like learning new languages, both programming and speaking. I work as a lead developer in a company called Protel, which is in Turkey, and we build POS systems in the cloud. And we mostly use Ruby for that. And recently, we started using Crystal also, and it's been going great. We are building apps with Kemal, and I can assure you that it's really, fun and also really great to use. So let's talk about Crystal. How many of you have heard about Crystal here? Whoa, I'm amazed by that because, yeah, it's great. Well, Crystal is like the new kid in the block, but most of the Rubies feel like they are at home because it's derived from Ruby. So think of Ruby, but which is nearly as fast as C. Like, does it even make sense? How can something like that exist? So when I first about that, I was like, seriously? And I was like this. How can this be possible? Technically, it's not, something like magic or something. And I thought that if it exists, then it's gonna be awesome because it's as beautiful as Ruby, yet as fast as C. So, and then I ventured into it and then installed it. And this is the first program I wrote. It's not necessarily the best one, but it's a Fibonacci sequence that calculates the given number. And you can see that it's exactly both valid Ruby code and both valid Crystal code. So I run it, like you see, and just did a quick benchmark on that at my first try. And it just worked, by the way. And it's like Ruby's like 15 seconds, and Crystal's like 20 times faster. So I was really, really, really amazed. And I was so happy because we were looking for, alternatives like faster ones. But, I respect Go, but I don't like it. So I didn't want to use it anyway. So I was like this. Oh, God, this is what I'm looking for. This is happiness, So we started investing in it. But still, I had the question of how can this be possible? So back to our question, that's LLVM. So that's practically some magic, some voodoo or something like that. So I discovered that thing called LLVM, and I started reading about it. And yeah, it's like really insane stuff. And then it's like I had mind explosions. I started reading Crystal source code. By the way, it's also Crystal self-hosted, so written in Crystal itself. So I thought at first, okay, Ruby is written in C, but how come Crystal is written in Crystal? So I learned a lot of stuff about that. And like I said, I get enlightened like this. And there my journey started. So why don't we take a look at Crystal's primary features? So Crystal, it's like Ruby, but not necessarily compatible. So unfortunately not, it won't run Rails, so don't ask me about that. It takes too much from Ruby, all the idioms, all the syntactic sugar, you know, all the beautiful stuff. And like I said, you can be productive from day zero. It's like you go in there, you do something, and it works. And that's a great feeling, because I babbled with Rust, and it was like, I can't even compile even a simple hello world, and I felt like stupid. Maybe I am, I don't know. But unlike Ruby, Crystal is compiled, which means that it has a smart compiler which catches all the errors that we get at runtime in Ruby. So that's a great thing. And also, LLVM gives us really free optimizations, which are great, and it makes Crystal much more faster. And Crystal is like, you know, Ruby, and it has a global type inference, so you don't have to write types all the time. You just have to write them when necessary, and most of the times you don't have to. And Crystal has really simple concurrency model based around CSP like Go. So you just use channels, and it's really good. It's evented, so it doesn't block, and it's pretty fast, I can assure you that. And the thing is that you all know that Ruby is kind of dangerous, right? Because you can open a class and do some eval stuff and then inject some, I don't know, hacky stuff into it. Well, in Crystal, you can't do that exactly, because there is no eval and there is no send. You have macros, and macros are great, and you get all that stuff at compile time without losing any performance. And all that codes are evaluated at compile time, which means there is no runtime performance penalty. And probably this is my favorite feature. It's native code, you know, just like Go or Rust or anything other like that. Thanks to LLVM, it compiles down to native code, and it's super easy to deploy your applications or your binary. And it's like my favorite feature. And by the way, Ruby is awesome. At least that's what I think. I think it's the most beautiful programming language out there, and that's why I'm really happy about it. So let's get back to our original topic here. I'm gonna be talking about Kemal, a web framework which I created in Crystal. And it has a great website. You can go there and check the documentation, and it's cool. So when someone asks me about Kemal, I mostly say that it's simple, fast, and modern. Like, it has everything you need when trying to build some web application nowadays. And the thing is that normally you sacrifice one of those if you want the two others. Like, if you want to be fast, then you sacrifice the others, maybe simplicity or modern stuff. But the thing is that Kemal achieves all of those without sacrificing anything. So that's also really amazing. So let's take a look at features. I'm gonna deep dive into each one of those, so you can take a look at here. It's like all the stuff that you need, like I said. It does even have a built-in WebSocket handler, so you don't have to use anything like Node or different process like in Ruby. So let's dive into it and take a look. First comes the simple part. How many have you used Sinatra before? Because I know that this is like the same stuff for you, but that's exactly the case here. It's like you just require it, and then you specify your HTTP word and your root, and that's it. Now we are returning a JSON response here, by the way, and the last return is what it gets, what it returns. And you just say Kemal.run, and it runs the server. So pretty simple. I think it's as simple as it gets. Like, I can't imagine any other way. So let's move on. So this is also the REST convention. Like, you have all the HTTP words here, like get pause, put, patch, delete, anything that you need for the RESTful convention. And yeah, you can have like many roots, but different verb. Moving on, I think this is, for us Ruby is like pain to do in Ruby because there is no, evented stuff baked into the core of Ruby. So you have to use either event machine or something like, or Celluloid or something like that. But in Crystal has a event loop, so you can just build stuff like this. For example, this is a full-blown chat application, which is also on Heroku, by the way. You can check it out. And the thing is that this is all it takes to write something like that. Like, there is some difference there. For example, to hold an array of strings, you need to specify types. Like I said that sometimes you have to specify types, at least for now. I think it's gonna be redundant in the future. And then you specify a WebSocket handler like this, you give it a root, and then you can access the underlying socket from there and do what you want. Like pushing it into an array, and then when a message comes in, you just echo back. So I think this is super simple. And the thing is that this is like, just consumes around 1 megabytes of memory, so it's like crazy. And the CPU usage is also super low, so you can handle like tens of thousands of client with the server. And this is also pretty interesting. The context of a request is a stream. Basically, it derives from an I/O stream so that you can access it and you can modify it later. Like you send the response first, and then you can do stuff like streaming or halting the stream or writing later. So it's like server-side events, but it's a bit more powerful because you can do whatever you want with that stream. And for example, you can also access this stream from other middlewares, which I'm gonna show a bit later. And the thing is that this loop here doesn't block. I mean, it's evented, but it doesn't block all the clients. For example, if you do that in Node, you're gonna block the whole server with sleep, and all the clients are gonna wait forever. In Crystal, we have something called Fiber, which is like lightweight threads, and it's like super cheap to create. So each client has its own fiber there. So that's why it's not blocking. And you can spam like tens of thousands or millions of fibers on a single CPU core. Moving on, the parameter parsing thing is kind of, hard to get actually, because you have to think of performance and you have to do all those stuff when it's needed, when it's, called actually. And the thing is that it's like pretty simple, as you see. Like you can parse a form body, like context params dot body and the key of the value. But interesting stuff there again. Sometimes you have to cast. Sorry, I don't have a pointer, so I can't show you that, I think. Sometimes you have to cast. For example, we cast the name to string or the age to int32. So that's also different from Ruby. And in case of JSON is interesting because you can have lots of nested stuff there, and sometimes it's hard to parse. And when you're in a compiled language like Crystal, and when there is a dynamic JSON that you don't know the types before, it gets kinda, hard to parse. But we got that with Kemal, and you can just access the JSON with params.json, and the key is converted for you. Or also, if you want, you can cast it to anything else, and then send the response back, like you can concatenate a string or something. So that's it. And moving on to, this is like the basic building block of Kemal. Kemal itself is also middleware, by the way. And instead of, most of the Rails developers tend to use filters. It's like there's lots of filters in a controller, like tens of them or so, and it makes maintenance really hard. So that's why I think middlewares are much more better, and it lets you encapsulate your logic in a different layer instead of just one big heavy controller there. So, like I said, you can create your own middlewares like this. You just inherit from HTTP handler, and there is this call method. It's like pretty similar to rec, but the difference is that the context is an IO, and it contains the request and response, a bit different from that. And then you can do, for example, an authentication control here on the header, and then if it's successful, you can just pass it to next handler. And it's like pretty, good for your architecture. You just keep it in a separate way. And to add this handler to your middleware chain, you just use kemal.config add handler, and the handler just add it to your handler list. For example, let's take a look at how Kemal is built. This is like the Kemal itself. It has 4 main core middlewares. When a request comes in, it goes through. The first handler is common log handler, so it starts logging the stuff. It starts counting how much it's gonna take, and then you can disable it if you want, by the way. This is optional, on by default, but you can disable it. And if you want, you can also write your own logger, like you don't wanna just log the time or whatever you want. You can replace it, it's pretty similar. And the next one is exception handler, like if the server is giving you 500, the exception handler will help you, like pre-stack trace. And you can also customize your own errors, like you just want some custom 404 page. You can just do that, it's pretty simpler. And then later, the context is passed to static file handler. This is also optional, by the way. You can disable it. And if you disable logging and static file handling, it will be much more faster. And this static file handler handles all your assets, like files, like images, like JS, CSS. And it's like pretty fast. You don't necessarily have to have Nginx or something proxying all your assets. And the most important one is root handler, which uses a radix tree algorithm to match all that HTTP routing. And it's quite fast, like we simulated the GitHub API with 200 routes or something, and it's like more than 1 million route matches per second for a given route, so it's pretty fast. So, moving on with middlewares, there are also optional built-in middlewares that you can use. For example, there is session middleware, but session is, for now, it's just in-memory based, so all your sessions are gone if you just kill your application or restart it. And we are building other file storage session middleware, and it's gonna be ready soon, I think. And it has a CSRF middleware to protect you from reply attacks on your forms. A simple HTTP authentication, basic out middleware there. And also, there is this SSL middleware, which is also pretty simple to use. You just specify your key and your certificate file, and that's it. You don't have to have, like I said, Nginx or something. So, this one is pretty familiar to Rails guys, I think. These are filters which executes either before or after your request. So it's a nice way of drying up your code, but like I said, if you can just use a middleware. But if you can't, you can do something like before get and specify the route, and then do stuff like setting the content type of your response. Or, for example, here, after the request, we just do something like update the cache. So this is like pretty useful, easy to use, but you just don't use too much because it gets messy. I don't like it. And this is view templating. We have something called Kilt. So it's basically like Tilt, but for Crystal. And there is like currently two main templating languages out there. One is ECR, which is like ERB in Ruby. So you can either use ECR or you can use Slang, which is like Slim in Ruby. So it's practically the same. But there is one big difference there. All the templates are compiled at compile time and compiles down into just one string. So it's pretty efficient. You don't do runtime stuff there. It just gets compiled at compile time, and there's actually no performance penalty of doing heavy templating there. So it's great. Also, you can specify an application layout like you do in Rails or any other stuff. And it just yields the content so that you can use it in your application. Moving on, like I said at the start, it's fast. And the thing is that who doesn't like some, meaningless micro benchmarks? And there's this. Can you see that? There is some code there. It's like basically sending hello world. And it's valid in Snatra and also valid in Kemal. And I use WRK to benchmark with 100 connections and 30 seconds duration. And it's like, there's like pretty much difference there. For example, if you disable logging, like I say, you can get like 100K requests per second, and the response times are under 1 millisecond. It's like 50 microseconds or something. And Sinatra is, it's good, but still, the difference is pretty big. Meanwhile, this is a micro benchmark, so take it with a grain of salt, and your performance may vary on your real-world application. So there is this big question, right? This is all good and shiny, the numbers are great, but is there anyone actually using this in production, right? For example, I can talk about Kemal till morning, but it doesn't even matter if no one ever uses it. So I think that's a bit metric. And yeah, it's in production. So these are one of the main companies that are using it. There is Sidekick. How many of you have used Sidekick before? Great. Sidekick is like background processing framework, the most popular for Ruby. And recently, the Sidekick creator started using Crystal, and he ported Crystal to Sidekick. Sidekick to Crystal, sorry. And the things that he uses Kemal to render all that control dashboards and all that web UI, and he says that it's pretty great and it's fast. And he compiles all that thing into single binary, like you don't have to install Sidekick there, because Sidekick is just a one binary. And Rainforest, it's a startup in US, I think, and they use this to do some microservices. Like I said, it's in production. And my company, Protel, we also use this. And I think it's safe to say that it's a Fortune 500 company that you may all know the name. And we are doing payment stuff, like the API is doing heavy payment stuff, getting hit like 100 requests per second or more. And it's like really great. There is actually no load or whatsoever. And we had to have like, I don't know, maybe 100 unicorn workers to handle that load. But a single Camel process can handle it like, without breaking a sweat. So it's amazing. And yeah, we are investing into Crystal. And I think it's working great. And there is also one other startup in Turkey, which is basically like Twilio, does SMS stuff and VoIP stuff. And they are also having scaling problems with Ruby, and they turn to Kemal, and now it's all unicorns and butterflies, I think, for him. Moving on, I wrote a short book about Crystal. Actually, it's named Crystal for Rubies, but if you are coming from a dynamic language like Python, like PHP, or something like JavaScript, you can just read it. It's for the ones who doesn't much know about types and stuff. And it's free. You can download it, read it on your Kindle, on your tablet. It's just free. Just use it. It's not so complete, but I think it's a great start if you want. And there's the Crystal documentation. It's not complete though, but it's I like it. You know, it's written with Gitbook, I think, and it's pretty simple to read. You can learn so much from there, like about types, union types, macros, on all that stuff. Be sure to check it out. And if anyone has questions about either with Crystal or Kemal, I'm happy to answer about it. And yeah, thank you. And by the way, one last thing. I have Kemal stickers there. If you like Serdar cool, just get it, grab it. It's free. Thank you.
Hi.
Hello.
Very cool project.
Thank you.
You mentioned Rec. So Rec is kind of the unifying thing in the Ruby world, that sort of underlying technology of all the web frameworks. Are you following the same spec, or is there already like another implementation like Rec for Crystal?
Yeah, that's a nice question. The thing is that Ruby is, you know, like 20 years old or something, and there wasn't anything HTTP related stuff in core. So that's why there is Rec. But in Crystal, HTTP is built in, so you don't have to have something like that. Instead, you just use the standard HTTP, and that's it. You have your server.
Hello. What's the state of database drivers in Crystal?
Nice question. The thing is that we have Postgres, MySQL, SQLite, and those are all working well. At least we are using PG right now, Postgres, and it's okay. But still, it needs to be much more polished, I think. And also, there is this official project coming by. It's Crystal DB, which is going to be a unified API for all the drivers, so it's going to be becoming better. And we don't have active record. I mean, we have it, but it's not like, you know, not in Railsware.
Okay, that was a very interesting presentation, Serdar. Thank you very much.
Thank you.